This is the Instron mechanical tester. It has a 30 kilonewton load cell, so it can go well above and beyond what the Mark 10 can do. The first thing, though, same with the Mark 10, is to make sure that you're not going to break the load cell. So make sure that your maximum expected force is well below 30 kilonewtons. If you're up to 20, 29 kilonewtons, then maybe reconsider what kind of material you're testing or the cross-sectional area. But yeah, just make sure that before you start, that you're not going to break anything. Then you can come over to here and type in the username and password. So it will be general with a capital G. And then the password is GenUser, all lowercase. Then you should come to this screen. What you're going to do is you're going to press test. And because I'm going to be doing a tension test today, I'm going to select general tension. There's also general compression somewhere, and general 3-point bend. If you need a different custom test, then talk to me or whoever is the TO at the time, and they can help you make that happen. So I'm going to select general tension. And this general tension method functions pretty much the same as the Mark 10 did. So you can choose your rate. I'm going to choose 15 millimeters per minute. You can choose to write a note. You can choose to alter these values. These values just give you outputs like Young's modulus and other things like that. I'm not going to care about those because all I want is force displacement. Then I'm going to click balance all. I'm going to have to click that again later when I move the grips, but it can't hurt to press it multiple times. And I'm going to open this door. So once again, we're going to go down here. This is where all the grips are. I'm going to choose the tension grips.
Yep.
So I'm going to put this tension grip on. I'm going to make sure that these teeth, these springs, face me. Then I'm going to put a pin through. Sometimes it can be hard to find exactly where the pin goes. Then I'm going to scroll this down until it's tight, but not too tight. Then I'm going to put the other grip in. Once again, I'm going to make sure that the springs face me. I'm going to put a pin through. Then I'm going to scroll that to the top. Now, you're going to put your sample in. Well, first you can move it down. Let's see. A little bit more. Okay. Then I'm going to put my sample in, which in this case is part of a zip tie. I'm going to put my sample in, and then I'm going to turn this so that it slowly clamps down on it. I'm going to put in the other end. Tight, and I'm close the door. I'm going to move it up so that it's just barely in tension. Okay. And then I'm going to zero the forces and displacement by pressing balance on. In order to move it up and down like I was doing, you can press, jog up, jog down. The longer you hold it, the faster it'll go. You can also use the fine position to change the displacement by less than a millimeter. So, once you've balanced all, you've checked that your rate is okay, then what you're going to do is you're just going to start your test. So it's meant to stop when it breaks, but for some reason it didn't register a break detect. But once it's done, and you can either press stop or it'll stop itself, then you have all these numbers down here. So because I stopped and started it multiple times, my numbers are a bit skewy, but it will show you the maximum force, displacement at that maximum force. It'll try to give an estimate of Young's modulus. You're probably better off just doing it yourself. Anyway, once you're done with this, then you press the export button and you export to CSV file 2. There, you can save it as whatever you want. You can put it in your own folder. You can do whatever you want with it. And then you can put it onto a USB drive, whatever. If you want a PDF, I think you can print a PDF, as in like save to a PDF, like so. And that's it. That's how you use the Instron. Once again, if you want more complicated methods or if you want to make your own methods, just contact me or whoever the TO is for the Instron at the time, and they'll be happy to help you.